Hello, in this video I'm going to talk about rules for subderivations and strategies for doing them. I'm also going to be doing a video with example derivations involving subderivations, and I really highly recommend you watch that video as well. You'll find it really helpful and illuminating. So, let's talk about rules for subderivations. So, a show line can be added on any line whatsoever. Why? They don't need a justification, because all you're saying when you write a show line is I'm trying to show something, and that needs no justification. You can also make assumptions with any show line you want, although they always need to be made on the line immediately after the show line. So if you're trying to show, if you do a subderivation of a conditional, you can make a conditional assumption, and you always want to do that. You can cite a show line, but only once it's been canceled. So once you cancel it, you can use it. Before it's canceled, you can't use it, because you haven't established that this thing you're trying to show really is true. From any given line, if you decide to apply a boxing and canceling method, CD or DD, you can only cancel the closest uncanceled show line. You can't cancel other show lines. That's because this new show line you introduced may rely on an assumption, and that assumption is legitimate for showing that line, but it's not legitimate for showing any other lines. So once you introduce a show line, that's the line you have to cancel. Once you're done with it, you can then cancel other lines, but not until it's canceled. And that means that each show line is canceled separately. So there's always going to be a particular show line you're working on. You get rid of that one, or you cancel it, and then you'll be working on a different show line. And it's always one show line is canceled at a time. Once a line is boxed, you can't cite it. Why? Well, because it relies on when you introduce a show line, then you may put in an assumption, and then the reasoning underneath that show line may rely on that assumption. Once you box and cancel that show line, you don't want to rely on that assumption anymore. The assumption was legitimate for that show line, but it's not legitimate for other show lines. And you could do mistakes in reasoning. You could reason invalidly if you didn't do that. So you need to say, aha, okay, that reasoning used that assumption, which was fine for showing that thing, but I've shown that thing, and so I'm not making that assumption anymore, and so I can't rely on that assumption anymore, and so I'm going to box those lines to indicate that I'm not going to rely on those lines anymore. Okay, so those are rules. What about the strategy? How do you know which subderivations to do when? Well, the first thing we want to think about is we have had 5 steps so far in our derivations. Now we have 6. The first step is show the conclusion. Second step is assume CD if you're trying to show a conditional. The third step is enter the premises if there are any. If it's a theorem, there won't be. The fourth step is to apply your inference rules. And then the derivation might get stuck. It may be that there are not any fruitful inference rule applications to make. And it's not that you can't find them, it's that there aren't any. And if the derivation is stuck in that sense, then you would do a subderivation. And then at some point you'll end up boxing and canceling. So we're really going to focus on this line 5 in this video. What subderivation should I do when the derivation is stuck, and what do I mean by a stuck derivation anyway? So you can always apply rules, right? Because you can always apply double negation or adjunction and make stuff happen, but it may be completely useless. So the derivation is stuck when all the rule applications that are possible to make don't move any closer to boxing and canceling. Now, it's not that you trying to find the derivation can't find the applications. It's that, in fact, there aren't any. So the derivation isn't stuck when you can't find rule applications. It's stuck when there aren't any useful rule applications. So you need to be confident that, okay, I've surveyed this, I know how to find the rule applications, and there aren't any. And at that point, you would want to do a subderivation. But subderivations will only be helpful if there really aren't any more fruitful rule applications. It's not like I'm saying, oh, you're supposed to do these other rules, and so don't do a subderivation unless you're sure about that. It's that the subderivation won't help. If there are other fruitful rule applications to make, then doing a subderivation instead is not going to help. It's just going to make the derivation get more complex and confusing. So you really want to be sure, do a subderivation only when the derivation is stuck, because otherwise you're going in a bad direction. So subderivations, if there are fruitful rule applications, but you haven't found them, a subderivation will not help. Okay. So stuck is there are no more rule applications that will be helpful to make. Now, a big part of the reason why subderivations work is that because when you enter a new show line, you then get to make a new assumption, and that will then allow you to apply inference rules. So in the previous video, we're trying to show if P then that if P only if Q, then not Q only if not P. And so on our third line, we said show if not Q, then not P, and then we made the assumption not Q. And that assumption not Q, we were then able to do modus tollens with an old line if P then Q. So part of the reason why subderivations work is because you get to make an assumption. And what will that assumption do? What it will help you do is it helps you to box and cancel the new show line. So you need to think, okay, I make the new show line because it's going to help me with the main derivation. I'm going to be successful in boxing and canceling the new show line because I get to make a new assumption. But you don't actually make the new show line because it will give you an assumption. The assumption is only going to help you box and cancel the new show line. You make the new show line because once you box and cancel it, it's going to help you with the whole derivation. Once you box and cancel the new line, the new show line, that assumption isn't helpful anymore. So you want to choose a new show line that will help you complete the main derivation, and then you'll get to make an assumption, and that will help you complete the subderivation. So still, what subderivation should I do? Well, first of all, make sure the derivation really is stuck. And secondly, never show a line you already have. Never, ever, ever. Why? All that subderivation will do is you'll end up canceling that show line, and all it does is give you then that line that you just canceled. Well, if you already have that line, then the subderivation, if you just do a subderivation of that line again, you will get nowhere. And so there's no, it doesn't help you. It's just adding excess confusing lines. So never show a line you already have. Instead, show a line that will help you complete the derivation. There are two ways a new line might help you complete the derivation. One is it will just let you immediately, once you've shown it, box and cancel the main derivation. And that's what happened in the example in the previous video. The first show line, the consequent was if not Q, then not P. And we said, okay, I'm going to show that. And once we box and canceled our subderivation, we had if not Q, then not P, and that let us immediately box and cancel the main derivation. So that's what you'd like to do. You'd like to show something that will let you box and cancel the main derivation immediately once you get it. You might not be able to do that, and what you then would do is you say, okay, well, I will at least apply inference rules. At least then maybe I can get a line that will help me apply inference rules to old lines. And so we'll see some examples of that. But one is better than two, because your goal is always just to box and cancel. And so you want to choose a subderivation that will let you box and cancel, and not one that will help you, that will let you apply inference rules. A common thing that happens is, okay, well, I was trying to show I'm working on a show line that's a conditional. Well, what's going to let me box and cancel that conditional? It's consequent, so let me show it's consequent. That's what we did in the previous example video. And this is such a common thing to do that we actually have a shortcut built into the program called show cons. Just like the first line of every derivation, you can write show conc for show conclusion, and it will write out the conclusion, whatever it is. If you're trying to show a conditional and you think I want to do a subderivation, if you write out show cons, then the program will write in the subderivation for you. So the most common subderivation that you will be doing right now is, I'm trying to show a conditional, I'm stuck. If I get its consequent, I'll be able to, or the derivation is stuck. If I get the consequent, I'll be able to box and cancel the derivation. Let me show the consequent. And, oh, look, I'll use the shortcut in the program. So we have these 6 steps. Show the conclusion, make an assumption, assume CD if it's relevant, enter the premises, apply the inference rules. If the derivation is stuck, do a subderivation. Stuck means, are there no for rule applications? There aren't. And what should I do a subderivation of? A line that will help me box and cancel the main derivation. And I will first then box and cancel my subderivation. And then having done so, I will move towards boxing and canceling the main derivation. So I'll illustrate these steps in some examples in another video. And you really should watch that. I think you'll find it very helpful.